So with sets, we have notation that helps us define a set because it's much easier to use notation than it is to write out all of the words or information that you want to use. If you're talking about sets over and over, it's nice to have a short way to describe it. So when we want to describe set A, for example, it will look like this. And just some features of the set. It starts with the letter that represents the set, and then equals. And this is I call them squigglies, but they're really braces. And they look like this if I draw a really big one for you. And the other side, the other end of the set has one that looks like that. So those are braces or squigglies, and they surround a set, so they define the things that are actually in the set. So an element of a set is a member of that set. And for example, for the set A that we just defined, we could say that 2 is an element of, and it's a funny looking E that looks like a C with a line in the middle, and then we put the name of the set. 2 is an element of A. Not an element of a set, I can pick some other thing that is not in the set A. For example, the number 3. 3 is, draw that element symbol again, then put a not. Not an element of A because the number 3 is not listed in the set that's named A. Roster method. That roster notation is a way to list out every element in a set. If we have equal sets, they will have exactly the same elements. And we would denote that as A equals B. Now, one more definition and then we'll look at some examples, but the cardinal number of a set is the number of elements that the set has. And we show that using, it looks like an absolute value. If you remember from the beginning of chapter 9, it looks like absolute value, but it's for sets in set notation, it is the cardinal number, and it's talking about how many elements are in the set. So for A, it would look like this. The cardinal number of A equals, and then we would just go count. I see 1, 2, 3, 4, 5 elements in this set. So the cardinal number for A is 5. All right, let's take a look at an example. Use the roster method to represent set S, the set of states in the United States that begin with the letter M. Then find the cardinal number of S. So to start with the roster method, we'll say S equals, and put the left squiggly, and then I need to start listing out all those states that begin with M. And if you are not sure, let's just Google it. So let's take a look. So here's a list of states, and we wanted all the ones that started with M. And so I'm scrolling down a little bit further, and I can see them there. I'm going to get all tricky and use snipping tool and just snip all the way down to Montana because that's the last one that starts with an M. And we'll put that away for a second. So it's going to disappear as soon as I start writing, but Maine, Maryland, Massachusetts, so we'll start with them. Michigan, Minnesota, Mississippi, Missouri, and Montana. And I'm looking through that list. I've actually been in every one of the M states. So there we've listed them out. Remember that set notation has the letter for the set, an equal sign, followed by the squiggly, the opening squiggly or opening brace for the set, a list of every element in the set, and they're separated, as you can see, by commas, and then ending with a closing brace or squiggly. Then we need to find the cardinal number for S. So I'll write that, the cardinal number for S, and then I can just count 1, 2, 3, 4, 5, 6, 7, 8. So the cardinal number for S is 8. Give an example of a set that cannot be listed using the roster method. And so we're wondering about what kind of sets can you not list out all of the elements. And they're going to be like where the set contains real numbers, for example. And it could be the set of all integers. And that cannot be listed out. But we can use the ellipsis or the dot, dot, dot to help us. So we can do, for example, if we wanted to do the set of all integers, we could do z equals dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, 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 and then the ending squiggly. And so in that way, it's sort of a hybrid roster form, but that way we can use these ellipses to say things go on and on in that direction, and then on the right-hand side, things go on and on in the positive direction with the numbers. And we can't list every single number. It's impossible. So here's a note for you. The order of elements in a set does not matter. So I could, with this set, if I'm trying to use an ellipsis, however, it does make a difference where you put it and what it's continuing, because it's meaning that whatever the pattern is that came before is going to continue. But in this example where I use the states that began with an M, I would not have had to put them in this same order that we wrote out here. It could start with Montana, have Massachusetts next, then Missouri. It would not matter what order I put those state names. As long as I had all of the state names, then they would be equivalent.